Hello, we would like to introduce you to our CytoPatch software that goes with our CytoPatch device. So we just start the CytoPatch software, and when it finishes loading, we log in. So we click OK, and we have access now to the CytoPatch software. And you can see on the left corner we have repositories group into various categories. We have the assays. You can see various pre-configured assays, and we have step process that you can use to build a complete assay from simple to complex. So you can see various step processes. We close that window, and then we open templates, and we have templates that allow the user to be able to drag and put in various pulses and execute. We have liquid handling steps which one can use to handle various drag applications. We have pulse protocols that you can choose from, drag and place on your template to execute. We have for various ion channels, and you have the options to modify or edit um, the pulse protocols. Each have to, after editing, you accept and save, and you're ready to run that. We have tools for the system where if one wants to manually execute some tools to be able to run the system. And we also have maintenance tools for cleaning, removing chips, and doing daily startup and weekly startup, all daily shutdown and weekly shutdown. So we can see here as a window, and we have a display window. When you click on general, you can see the various settings of the CytoPatch software. And so we will now try to build our own assay. So first of all, we click on new, and we have to give a name to the assay that we want to build. So I will say VGig2K. We're doing demonstrations, so I'll say demo for the name of that assay. And after typing in the name, I click OK and close. And then we can see the name VGig2K demo with a steady test cell 0. So I'll make more space. So I'll click on the step process to enlarge it, and then I will start building my assay. So first of all, I will pick assay start, where the whole chip process is being filled and primed, ready for cell catch. So I'll go for a cell, and then cell is being displayed into the chamber. We have a cell catch, and then we make a gigaseal. And in the gigaseal, I might say here we have automated CFAS compensation. After that, I go for whole cell. And in the whole cell also we have C-slope compensations. And then I drag in set for holding potential. Now, if one requires additional compensation, we have tools or step process that you can drag into and then do further compensation if one or the user wishes to do so. And we also have in the set vhold, setting the holding potential, you can also define the holding potential to your preference. Now I will go for assay end, and thereafter I will insert my liquid template to be able to execute the experiment between after holding potential and assay end. So let's say I want to execute putting a template where I will test the response or activation of the channel under consideration. So let's assume I'm using Hexel. I just want to put a single pulse protocol to test the HEG activation before I execute further template or protocol. So simply I will say HEG current check 1, because it's very important to have a unique name, because the name or the software allows you to name your own template or modify the name so it doesn't override what is already existing. So I will drag in, go into pulse protocol and drag in HEG standard, where after whole cell setting the holding potential, I'll just have a brief look at the HEG activation to have an idea whether I have a good response or not. And then I'll go to template and drag voltage gated ion channel loop, where I'll be able to execute more than one pulse protocol. So I drag that and name it 1. And then I will go to liquid handling and then choose perfusion TC on, which means that perfusion transport channel on, which is more or less like a control, where one will be able to see the response or the activation of HEG before proceeding for drug application. And the TC Perfection On allows the user to be able to define a time duration, how long you want to record or do the control experiment. So you can see from here on the left below, you can see the loop duration. You can set the time for this template. I'll go for a next template and I will name it 2, click OK and close, and this will allow me to be able to dispense compound. So I'll go to liquid handling and then define a condition that says get compound, and the dispenser needle will go get compound. But what we want to do is, whilst getting compound, we want to test the response and see whether we have our HEG activation or something might have gone wrong during this process. So I'll drag in pause protocol, HEG activation for channel 1 and then for channel 2. And I will want to put in a template, which will be a third template to dispense the compound. So I'll name it VGIG loop 3, OK and close. And then I will put a condition in after getting a compound to dispense the compound. So we go to liquid handling, and then I will pick a step process, dispense compound. And whilst dispensing compound, we want to test the HEG activation. So we go to pause protocol and then drag HEG standard pause protocol into channel 1 and also for channel 2. There we go. And dispense compound also, when you click on the template, it allows the user to define the time duration at which you want to dispense a compound and test your response. Now, assuming we want to apply more than one compound, so just click on the compound rack displayed on get compound, and we can define the position of the compounds in the compound rack with the window that is popped up. And we choose a position, and we write the name of the compounds for each of the positions. If we're using the same compound, it's going to be quinidine for position A1, A2, A3, and A4. And thereafter, we want to write a concentration. So as we're doing dose-dependent concentration experiment, then we want to go for 0.1, 0.2, 0. Let's say 5, and 1. So we don't write a unit along the same column. We have a column where you have the unit on top defined, so we can drag the unit alongside. So we just pull the unit out, which is micromolar, for each of the position defined with the compounds in the compound rack. So just drag and select. After we drag and select the unit for our compounds, we just click OK, and we can see now we have a white highlighted position A1, A2, A3, and A4. And very importantly, we have to connect the template get compound and dispense compound with, so we can see that when we connect it, we see this red connecting button, which means that when the dispenser needs to get a compound, it just goes straight away to dispense the compound. Now we want to put in also another template to test the response after compound application. Now you can see that we try to overwrite already existing name of a single pause protocol. The system doesn't accept it because it doesn't allow overwriting of previous existing name of a template. So we have to rename it, and I say 1. And then I will drag in our pause protocol into that just to test the response after compound application, so we can smoothly end our assay. So put in test pulse for channel 1, channel 2, and then now we can end our assay. So dispense compound, we can define the time duration, as I said, for how long we want to monitor this event. And the user can do that by looking or changing the parameter where we have the loop duration to define the time. Now get compound, we don't have to define a time duration because the movement of the picker and the dispenser needle to get a compound will determine the time duration which that event will take place. So the user don't need to define a time duration for that. So I would say after this point, we just look through and see whether our assay we build is properly in order for execution. And the other option I want to introduce you to is when you click on the pause protocol and you click on display window, you can see your waveform. And when you click below where you see the waveform functions, you can see the various parameters for the waveform you can edit. When you click on cursor measurement, you can see the defined position of the cursor and the meaning of each of the cursor and what they're measuring and what they're calculating. So the user has a free option to edit or make changes and accept and save. Well, I would say after this point, we're ready to go to start our asset. So before we start the asset, we have to click on begin, and then we enter the study. And I would say preferably it's good to enter the date or the date on the day you're doing the experiment, so that when we recall this data into the workflow manager, it's very organized and easy to follow up your data. So you enter the compound or the which you're using for your studies, and then you can enter the cell. So let's say we're using let me say hex 293 cell. We enter that information, and then yeah, I can delete the cell, and because we have cell above that, we click OK, and then we're ready to go. So when we click OK, a window is open for us to define the data storage path, and that is in CytoPatch on CP. Data storage is in the CP folder. So when we click Assay Start, then we begin the assay. Is going to ask for the position of the chip, and then we click OK, and then the information which we input into the workflow manager, now we have to recall, which we can see the pop-up window. We select the chip information we entered and the chip we're using. We click OK, and then the cell window will pop up for the cell window, and then we select the cell and it's OK. So at this point, I will say thank you for your attention, and this is the end of our video.